Okay, these are the answers to Blue Workbook page 61. And this page is dealing with this reference table H. So if we go to our reference table, table H, we will see, and we minimize it a little bit, we are going to see that it's the vapor pressure of four liquids: propanol, ethanol, water, and ethanoic acid. And we always look at the title of a graph and we look at the axis. We identify the axis. On the x-axis, we have the temperature. And on the y-axis, we have the pressure. Now, what I need you to notice, and sometimes a lot of students make a mistake or when they read this graph, is I want you to notice that the temperature on the x-axis goes up by 5, 10, 15, 20, 25. So it goes up by 5, but the vapor pressure goes up by 10, 20, 30, 40, 50. So, and what do we notice? We notice that as the temperature increases, what happens to the vapor pressure? As the temperature increases, the vapor pressure increases also. Let's understand that a little bit. What does that mean in terms of intermolecular forces? Because that's what they're trying to do. So let's take two liquids. Let's go back to our reference table. And we are going to take propanol, the two extremes. We're going to take propanol and ethanoic acid. And we are going to go over here on the dotted line. So we're going to see, let's say, at 75 degrees Celsius, we're going to see that ethanoic acid has approximately 10, 20, 22 kPa. So we're going to go back 22 for ethanoic acid. So we have ethanoic acid. The vapor pressure is approximately 22 kPa. I think the temperature we said 75 degrees Celsius, right? Is that what we said? Let's go back. $75, yes. And if we go up, we're going to see that propanol has approximately, what is it over here? 10, 20, 30, so approximately 180. Approximately 180. Because let me just draw a line just so that we can show that one. So we're talking about ethanoic acid right here. And we're talking about ethanol. Actually, you know, we have to be exact. So it's 160, 70, 80, 180, 85. Let's make it 185. So propanol is 185. Let's go ahead and see where is our reference table page. Okay, let's just, okay. So we're gonna go back to 185. Okay, so we say that we have two liquids. One is propanol and the other one is ethanoic acid. Which one has a higher vapor pressure? 185, propanol. Now, what is the vapor pressure? The definition of vapor pressure, you have to go and write them and look at find them on the orange workbook. It's the pressure of the vapor, the pressure of the gas. So we know some of that liquid will vaporize. and change from a liquid to a gas. And we know that the difference is the difference in the distance between the molecules. If the vapor pressure over here is 185 kPa and here is 22 kPa, where are we going to have more gas molecules? Where the 185, more molecules, there is more pressure. How about when there is only 22? Only a few. Now, let's see. When the vapor pressure is high, what does that mean? That the molecules had an easier time to escape out of the liquid. So what holds them in the liquid? The intermolecular forces. So high vapor pressure means weak intermolecular forces. But when the forces, the intermolecular forces are strong and they're holding these molecules in the liquid together, they have strong intermolecular forces and low vapor pressure. So weak intermolecular forces, high vapor pressure, strong intermolecular forces, low vapor pressure. Imagine, okay? So you have to remember that. And now that you understand that, let's go back to our graph. Let's go back to our graph. And what I want you to write on your periodic table, on your reference table, not periodic table. Propanone has high vapor pressure because it has weak intermolecular forces. And then I want you to write ethanoic acid has low vapor pressure because it has strong intermolecular forces. So you're going to see ethanoic acid has the strongest intermolecular forces out of the 4 liquids. That's why it has such a low vapor pressure at any temperature. You're going to see that the vapor pressure is going to be the lowest. And propanone has the highest vapor pressure. Okay, now another thing. This is 101.3 kPa is equal to 1 atmosphere. And it's also called the normal boiling point. Okay, so I need you to find these definitions and remember that the boiling point is the point, temperature at which the vapor pressure equals the atmospheric pressure. And when that atmospheric pressure is 1 atm, it's called the normal boiling point. So all you need to do over here is remember that high vapor pressure means weak intermolecular forces, low vapor pressure means strong intermolecular forces, and just read the graph. The normal boiling point is on the dot. For example, the normal boiling point for propanone is approximately, if we go down, it's going to be approximately 55 degrees Celsius. The normal boiling point for ethanol, it's approximately 80 degrees Celsius. The normal boiling point of water is 100 degrees Celsius, we know that. And the normal boiling point of ethanoic acid, it is 5, 10, 15, 117.5, let's say. Let's go and answer the questions on this page. So the definitions, it's just write in the definitions, go into your orange workbook and write in the definitions. Answer the following questions. Vapor pressure of a liquid depends on what factor? Let's go back to our graph. The vapor pressure of a liquid depends on what? Look, it's over here. It depends on the temperature. So you're going to go and write temperature. Vapor pressure depends on the temperature. As the temperature increases, vapor pressure increases also, direct relationship. Which of the four liquids on table H has the weakest intermolecular forces between the molecules? What did we say? Weakest intermolecular forces means highest vapor pressure. So if we go back, so let me just clear over here. Which one has the weakest intermolecular forces, did we say? And we wrote on our reference table. It's going to be propanone because no matter what the temperature is, here it's going to always have the highest vapor pressure. So we said weakest intermolecular forces, highest vapor pressure, and it's propanone. Which one has the strongest intermolecular forces? The one with the lowest vapor pressure. Which one has the lowest vapor pressure no matter what? The lowest vapor pressure is ethanoic acid. It always, at any temperature, is going to have the lowest vapor pressure. And we're going to write ethanoic acid. Explain why water boils at 100 degrees Celsius at normal atmospheric pressure. It's what we said before, because the vapor pressure of water equals the atmospheric pressure. Let's go on the second part, vapor pressure and temperature. This is just reading the graph. Determine the vapor pressure of each of the following substances. So we're going to have to go to the temperature and find propanone at 30 degrees Celsius. So let's go to propanone at 30 degrees Celsius. I'm going to find this. Okay, I'm going to draw this. Let's find propanone. Propanone is right over here. So at 30 degrees Celsius, we're going to go across and we're going to see that it's approximately here. So that means that it's approximately 38 degrees, 38. Oh, let me just look at the units. It's over here, sorry. 38. What are the units for vapor pressure? Do I have to remember? No, I don't. I just have to look at the graph. Oh, it's kPa. Okay, right here. So 38 kPa. Let's look at water, the vapor pressure of water at 75 degrees Celsius. 75 degrees Celsius. And let's find water. And water is approximately over here. So let's draw a line across to see where that lies. It's over here. So I will see that it's approximately 60, 70, 80, approximately 88 kPa. 88 kPa. So you have to remember that the temperature goes up by 5 and the pressure by 10. So 88 kPa. Ethanoic acid at 115. 100 is over here. 5, 10, 15. 5, 10, 15. Always double check. And they're asking for ethanoic acid. So this is the point where the graph meets. I'm going to go across and I'll see that it's approximately 92, 93. You're going to have a plus or minus 1 or 2 points. So I'll say 90, 93. Let's write over here. 93 kPa. Ethanol at 58 degrees Celsius. 58 degrees Celsius ethanol. 58, 50, 55, 60. So 55, 60. So 58 is approximately over here. And they're asking me for ethanol. So the point ethanol, I'm just going to follow the graph. This is the point. Come across. And I'll see it's approximately at 40, 45, 40, 44, approximately 44 degrees Celsius. I mean 44, not degrees Celsius, kPa, please. For kPa. We have to determine the boiling point at each given atmospheric pressure. So we have propanone at 50 kPa. What did we say? The boiling point is where the vapor pressure is equal to the atmospheric pressure. So when we have 50 kPa, and that's the vapor pressure, that is the atmospheric pressure, that is equal to the vapor pressure. So we're going to go at 50 kPa. So let's go at 50 kPa. So we're going to go over here. We're going to go at 50. And for what graph are they asking me for? They're asking me for propanone. Where's propanone? Over here. There's the point where that is. I'm just going to go over here. There's propanone. 30, 35. So I'm going to say approximately 36. So let's write approximately 30. No, I'm sorry. Did I go? Let me go back. So they said 50 kPa. So they said 50 kPa is over here. I did the other way. So 50 kPa is over here. I'm going to go across. Then it's over here. So I'm going to say 30, 35, 37. Okay, 37, 36, 37. So let's write over here 36 or 37 degrees Celsius. How about water at 120 kPa? Water at 120 kPa. 110, 120. Let's go across. Let's find water. Water is over here. Let's go down. You have to be careful that the temperature goes up by 5. So it's 105 degrees Celsius. So we're going to say 105 degrees Celsius. Let's go to number 15, ethanoic acid at 80 kPa. So 80 kPa, 50, 60, 70, 80. It's over here. And what graph, that we're looking at ethanoic acid. Ethanoic acid, this is the graph. So over here, the temperature goes up by 5, 105, 110. If I am to 110. So for number 15, we're going to write approximately 110. Somebody may say 111. There's going to be a plus or minus 1 or 2 points. Ethanol at 60 kPa. 60 kPa. Let's go find 60s over here. Let's find ethanol. Ethanol is over here. I'm going to follow this graph right here. Ethanol is approximately over here. It goes up by 5, 55, 60, 65. So I'm going to say approximately 66. So 66 over here. Let's clean. Degrees Celsius. Let's find the normal boiling point of each. When they are asking for the normal boiling point, the atmosphere is 1 atm, which is 101.3 kPa. And if we look at the graph, it's going to be on the dotted line. So propanol, ethanol, water, and ethanoic acid. So let's go back to the graph. This is the dotted line, and they want us to find out the boiling point of propanol, ethanol, water, and ethanoic acid. And we're going to see that this is the normal boiling point. So to find the boiling point, we need a temperature. Boiling point is a temperature. So we're going to go and we're going to find it. And we're going to see that propanol is approximately, if I am to draw the graph, we can say that it's approximately 66 or something. Ethanol is exactly at 80. Water is exactly at 100. And ethanoic acid is 100, 105, 10, 15, 18. So let's write over here. So we're going to say approximately 56 degrees Celsius over here for propanol. For ethanol, we're going to say approximately 80 degrees Celsius, 100 degrees Celsius, and 118 degrees Celsius. Those are the points over here for each one. So let's go back and write them. Here. So we're going to say, as we found them for propanol, it was 56 approximately 79 or 80 degrees Celsius, 100 degrees Celsius, 118 degrees Celsius. I hope that was helpful. Go over, it's just a simple reading of the graph.